Hello, scholars. This is Mr. Lowe. The purpose of this video recording is to just give you a recap and a synopsis of the word problem examples that we were working through over the course of section 1.3. Main thing to keep in mind here is solving linear equations is a big time focus of this particular class. So knowing these concepts extremely well will be beneficial to you as we go through the course of this school year. So I definitely want to take the time to make sure that we have a solid foundation of solving equations, but also with regards to the word problems that go with them. So here we are starting with two equations that not only are we solving equations, we are also evaluating an expression that goes with them. So if 5m plus 8 equals 7m plus 11, find the value of the expression 4m plus 3. So keep in mind, they're asking you what is the value of 4m plus 3, which is all well and good, except we don't know what m is equal to. But we can easily get what m is equal to by solving the equation that is next to it. 5m plus 8 equals 7m plus 11. So we solve the equation and we use it to evaluate the expression. So we've got variables on both sides, so we need to move one of the variables over. In this case, we can move the smaller variable. So that gives us 8 equals 2m plus 11. Now we continue solving. Take the 11 and we subtract it over. So negative 3 equals 2m, with the 11s dropping out. Then divide both sides by 2. We have negative 3 over 2 equal 2m. So now we know what m is equal to. We can go ahead and insert that into the expression. So 4 times negative 3 over 2. So we have 4 times negative 3, which is negative 12. Then divided by 2 gives us negative 6. And then negative 6 plus 3 is negative 3. So our final answer to this problem is negative 3. A lot of people will stop once they solve the equation, and that's not where you stop. You stop once you actually answered the question. So just keep that in mind. Problem 12 is the same way. Find the value of 3t plus 5 when 2t over 3 plus 7 equals negative 9. So again, 3t plus 5, we're looking for what that value is, but we don't know what t is equal to. Luckily, we have an equation that we can use to help solve that out. 2t over 3 plus 7 equals negative 9. So to start solving out the problem, subtract the 7 over. So you've got 2t over 3 equals negative 16. Now, there are a couple ways that you can solve out the problem from here. The way that I'm going to use is a fraction is another way of representing division. The opposite of division is multiplication. So take both sides and multiply times 3. So if we do that, the 3's drop out. You get 2t equals negative 48. Then divide both sides by 2. You have t equals negative 24. Again, all fine and dandy, but that's not the answer to the problem. We want to know what the expression is. So take negative 24, insert it into the expression. 3 times negative 24 is negative 72. Negative 72 plus 5, negative 67. So our final answer for that problem ends up being negative 67. Okay. Again, the key thing there is We use the equation to then go and solve the rest of the problem. Very important to pay attention to what they're asking us to do. So let's go on to another example. So problem 13 may be familiar to you from your geometry days. So find the measure of angle B in the given triangle. So one thing to remember about this particular problem, you're given 3 angles inside of a triangle. So you have to remember that the angles in a triangle must add to 180. Must add up to 180. So fundamental concept that carries over from geometry. So if we set it up, angle A, angle B, and angle C have to add up to 180 degrees. So 7x minus 11 plus 2x minus 3 plus 5x minus 2 equals 180. So that's first thing. Combine our like terms. So 7 plus 2 is 9. 9 plus 5 is 14x. Then we combine all of our numbers up. Negative 11, negative 3, negative 2 gives you negative 16. Now, you could have combined everything up in one step. I'm just showing it part by part so that you know where everything came from. Now we put in the rest of the work for the problem. Add 16 to both sides. So 14x equals 196. Divide by 14. So x equals 14. So this is great. X equals 14, but that's not the end of the problem because that's not what they asked us for. We were asked find the measure of angle B. So we take 14 and plug it in for x. So this is very, very similar to what we had with examples 11 and 12. 2x minus 3, take the 14 and plug it in. So 28 minus 3 gives you 25 degrees. So as it relates to a geometry problem, all the angles in a triangle inside of a triangle must add up to 180 degrees. Do not confuse that with a problem asking you for perimeter. Perimeter deals with sides. So all 3 sides would have to add up to whatever the perimeter happens to be. So just simple paying attention to it will work wonders. 14. Darren made $184 by giving 14 haircuts on Friday and Saturday. Haircuts on Friday are $12. Haircuts on Saturday are $15. How many haircuts did Darren do on Saturday? So, a couple things to keep in mind here. So he made $184 giving 14 haircuts on Friday and Saturday. So that means whatever he did on Friday plus whatever he did on Saturday has to equal 184 degrees. I mean, $184. So one thing we do know that on Friday, haircuts are $12. On Saturday, haircuts are $15. What we don't know is how many he did on each day. So we don't know 12 times what and 15 times what. So here's how we get the variables for that. So remember, he only has 14 hair. He only did 14 haircuts. So between the 2 days, it has to add up to 14. So let's think about that in terms of numbers. So if he did, for example, 3 on Friday, then he has to do 11 on Saturday. Why? Because 14 minus 3 gives you 11. If he did 6 on Friday, then he had to have done 8 on Saturday. Why? Because 14 minus 6 is 8. So right now we're just guessing at random numbers. We need something to help us get to the answer for this problem. So if he did X haircuts on Friday, then that means on Saturday he did 14 minus X. To get however many he did on Saturday, he has to do 14 minus the number he did on Friday. So now we have the expressions that we need to solve this problem. So 12 times the number of haircuts we're doing Friday, plus 15 times however many are left over, equals 184. So that's the equation that we need in order to solve this problem out. Takes a little bit of reasoning and a little bit of thinking, but we can get there. So let's work out 14. First is distributing. So 12x plus 15 times 14 gives us 210. 15 times negative x, negative 15x, equals 184. 12 minus 15 are like terms. Negative 3x plus 210 equals 184. Subtract 210. Negative 3x. So now if we do our computation, 184 minus the 210 gives us negative 26. Divide by negative 3. So you're going to find that x is equal to 8.6 repeating. But you can't do 0.6 of a haircut. At least I'm not going to pay for 0.6 of a haircut. So that's 9 haircuts on Friday. On Friday, you did 9 haircuts. That's nice. But they didn't ask for Friday. They asked for Saturday. So to get the Saturday haircuts, you have to do 14 minus 9, which is 5. So 5 haircuts on Saturday. 5 haircuts on Saturday. So again, not every equation is going to be simple. Some require a little bit of thinking to get the point across, such as with 14. 15. 2 students on the wrestling team are trying to make it to the same weight class. John weighs 144 pounds and plans to gain 5 pounds a week. Briscoe weighs 192 pounds and plans to lose 7 pounds a week. How many weeks will it take both students to be the same weight? So we have John who wants to equal Briscoe in this case. John who wants to equal Briscoe. So now we start setting up the problem. So in the case of John, he's weighing 144 pounds now, and he wants to gain 5 pounds a week. So gaining as a mathematical operation is adding. So that's plus 5 times the number of weeks he's going to be at this workout program. Briscoe weighs 192 pounds and plans to lose 7 pounds a week. So that's 192. Losing is subtraction, 7 pounds a week. And they want to be equal, so we set them equal to each other. We set the 2 parts equal to each other. So now we have our setup. It's up to us to now solve it. So we've got variables on both sides. So the smaller variable is negative 7. So we're going to add 7w to both sides. 144 plus 12w equals 192. Now we subtract 144 on both sides. So 12w equals 48. So finally dividing by 12, W equals 4. So it's going to take 4 weeks for John and Briscoe to make the same weight, to be the same weight as each other. So again, another application of figuring out what two quantities will equal each other. What quantities will equal each other. So 16. So 16 is going to use a little bit about averages. Jared scored 14 points in the first quarter, 9 points second quarter, 18 points in the third quarter of a basketball game. How many points does he need to score to finish with an average of 15 points per quarter? So one thing to keep in mind, there are 4 quarters in a basketball game. First quarter, second quarter, third quarter, fourth quarter. So he wants to average 15 points a quarter. So think about what it means to take an average. So to take an average, we have to take the sum divided by the number of values you have. Now, in any other situation, if we knew how much he scored in the fourth quarter, then we would take 14 plus 9 plus 18 plus however much they scored here divided by 4, and that would give us our average. So we want an average of 15, but we don't know how much is in that fourth quarter. We don't know how much he got in that fourth quarter, so that's where we give that variable x so that we can solve this problem out. And if we knew all 4 numbers, we can add them up, divide by 4, and keep it moving. In this case, we need an x in order to take care of it. So let's go ahead and solve this out. Looking at the problem, 14 plus 9 plus 18, we can add those up to get 41. Remember, a fraction represents division, and the opposite of division would be multiplication. So we need to multiply both sides by 4. We need to multiply both sides by 4. So cross out both parts. We have 41 plus x equals 60. Then it's a simple subtract 41 on both sides. You get x equals 19. So that means you need 19 points in the fourth quarter if you want this to happen. If you want that to happen, 19 points in the fourth quarter. So we were setting up equations there. In addition, we were working with an average to solve out our problem. All right, so this takes care of that regular part where we ended up finishing off. So the last two deal with consecutive integers. So this is a worthwhile concept to know, especially for those of you who are, once you take the SAT, this is a type of problem that does come up. So definitely a worthwhile concept to know. So the first thing that we have to keep in mind is, what is a consecutive integer? A consecutive integer, so consecutive basically means back-to-back numbers. Back-to-back numbers, numbers that follow each other. So, for example, 7 and 8 are consecutive integers because 8 comes after 7, immediately after 7. So numbers that follow each other are consecutive integers. So they want us to find 2 consecutive integers such that their sum is 89. So we need something plus something else to equal 89. And these two numbers have to be one right after the other. So they didn't give us anywhere to start. That's the problem. They didn't give us anywhere to start. So this first number, let's make that one x. So we just need somewhere to start, so x. Now, notice in this case, to get to the next number, to get from 7 to 8, we simply added 1. So to get from x to the next number, we're simply going to add 1. Because once we know the first number, all we have to do is add 1 to it. We have the second number. So there's our equation. X plus 1 equals 89. Now all that's left is for us to solve it. So x plus x combining like terms is 2x plus 1 equals 89. So subtract 1 on both sides. So 2x equals 88. Divide by 2, x equals 44. So there's our first number. So your first number is 44. And then it's real easy to get the next number. You add 1 to it. So 44 and 45 are it. And 44 plus 45, sure enough, is 89. So you might ask yourself, well, why do I have to do all that? Couldn't I just guess at numbers? You can guess at numbers, but unless you are correct on the first or second or very, very close try, you could be at it for a while. So algebraically, it hurries up and gets us there pretty quickly. So lastly, 3 consecutive odd integers. So consecutive is one right after the other. Now, when we say odd, we're being a little bit more specific. So consecutive odd integers. So an example of that, 7, 9, 11. So odd number, so you're looking at just odd numbers. But notice, instead of going by 2s, instead of going by 1s, you're going by 2s. So to go from 7 to 9, you're adding 2. To go from 9 to 11, you're adding 2. So instead of adding 1, you're adding 2. So keeping that in mind, find 3 consecutive odd integers. So we need 3 numbers this time. So x can be the first number. X plus 2 is the second number. And then x plus 4 is the third number. So if you're wondering where is x plus 4 coming from, so remember, we're adding 2. So x, if we add 2, gives you x plus 2. X plus 2, if we add 2, 2 plus 2 gives you 4. So that's where the 4 comes from. So find 3 consecutive odd integers such that they have an average of 13. So we're working with an average again. So average means take your numbers and add them up. So that's x plus 2 plus x plus 4. Divide by the number of numbers you have. This is 3 numbers. So divide by 3. We need an average of 13. We need an average of 13. So now we've got enough to be able to solve this out. So when we solve, we're going to combine like terms at the top. So 3x plus 6 divided by 3 equals 13. Again, remember, a fraction means division. The opposite of division is multiplication. So we're going to multiply both sides by 3. We're going to multiply both sides by 3. That's going to lead to the 3's dropping out. 3x plus 6 equals 39. Subtract 6 on both sides, so 3x equals 33. Divide both sides by 3, so x equals 11. So now we know where to kick things off. So if the first number is 11, then that means the second number is 11 plus 2, 13. The third number is 11 plus 4, 15. So 11, 13, 15 are your numbers. Those are your numbers that you're working with. So is it a ridiculously hard problem? Absolutely not. Not a hard problem. It does require you to put some thinking into it. That it does. So with that, again, this is a quick recap of the solving out word problems, etc., as it relates to solving equations. Notice that we solved different types of equations, variables on both sides, multi-step equations, so on and so forth. Again, if you want to get better with this, you've got to put it into work. With that being said, thank you very much. Hope this video is effective, and I will talk to you soon.